Good morning, everyone. So today we're going to be looking at yeast and we're going to be using it to blow up a balloon. So let's get started. So today we're going to be using a flask. We're going to be adding warm water. Warm water helps the yeast wake up and start to activate. So I'm going to add about 100 mils of water. Then I'm going to add a tablespoon of sugar. So this is the food for the yeast, and I'm going to dump it in using my funnel. And then I'm going to add a tablespoon of yeast. And we're going to shake it up. And then we're going to put a balloon on and wait for our yeast to make some carbon dioxide to blow this balloon up. So you can already see it's starting to go. It's coming to the top and I can see some bubbles. So while we wait for the yeast to make some carbon dioxide and fill this balloon, we're going to talk a little bit about yeast. So have you ever looked closely at a piece of sandwich bread? Like really closely. Notice all of those tiny holes. They probably got there thanks to tiny living organisms called yeast. Even though these organisms are too small to see with the naked eye, so if you look, each of these granules is a clump of single-celled yeast. So those are clumps. There's lots and lots and lots of yeast in them. So it's already starting to blow up. I can feel it. And if you look, you can see it foaming in the bottom. So even though these organisms are too small to see with the naked eye, they are indeed alive just like plants, animals, insects, and humans. In fact, we have some interesting things in common with these little creatures. When you breathe out, part of what you are exhaling is a gas known as carbon dioxide. Yeast also releases carbon dioxide when it is active, although it's way too small and simple an organism to have lungs. Yeast are so small you can't see individual ones very well. So how can you tell if they are alive or not? So now we can see as it's growing, it's producing carbon dioxide by eating the sugar that I've added and creating carbon dioxide. So when you buy a packet of baker's yeast at the store, the organisms inside are in a state of inactivity, so they don't need to eat. Keeping them cool and dry helps keep them preserved. But when you mix them into dough, they wake up and begin eating and making carbon dioxide. So you can see it started to make carbon dioxide. So there's a lot of bubbles in here. All of here is bubbles. And it's starting to rise up, and the carbon dioxide's formed in here. So the yeast eat the sugar and create carbon dioxide and ethanol. When you make yeast-based bread, you often have to wait for it to rise. During this step, the dough might appear to be growing, but what is really happening is that you're giving the tiny yeast organisms time to eat and create small pockets of carbon dioxide inside the dough, which is what makes the dough seem to grow larger and what leads to fluffy bread. Bread products that don't have yeast rise during baking thanks to other ingredients such as baking powder. So what is happening here is when the yeast gets warm water and some food, like sugar, they will become active, and as they eat the sugar and break it down for food, they release carbon dioxide, which fills up the balloon. Yeast is actually a type of fungus related to mushrooms. The type of yeast used for baking is usually Saccharomyces cerevisiae, but it is one of more than 1,000 species of yeast. Our own bodies actually have plenty of yeast species that live peacefully alongside and inside us. So, we've made some carbon dioxide with the balloon. This is a very fast growing one, and I can feel that it's given off some heat. So it's very happy with the sugar in there. So that is yeast blowing up the balloon. Now we're going to talk about air all around us. Air is all around you. Air is all around you. There is air down in a deep valley. There is air around a high mountain. Wherever you go, there is air. Cars and houses are filled with air. So are barns, sheds, dog houses, and bird houses. Cups are full of it, so are bowls, pots, and glasses that we drink out of. That's hard to believe because you can't see the air or smell it. You can't feel it either, except when it's moving or when you spin around. You can't see the air in a glass, but you can prove it is there. Try this experiment. Stuff a paper napkin into the bottom of a glass. Turn the glass upside down. If the napkin falls out, stuff it in tighter. Run a lot of water into the sink or put water in a big bowl. Color the water with a little food coloring. Not much, just enough to color it a little bit. Keep the glass upside down. Make sure it is straight up and down. Do not tip it. Push it all the way under the water or as far as you can. Lift the glass out of the water, turn it right side up, and take out the paper napkin. It is dry. The water did not touch it. The paper was under the water, but it did not get wet. Let's see why. Once again, put the napkin in the glass. Turn the glass upside down and push it under the water. Look at the glass through the water. The water does not go into it. It can't go in because there is air in the glass. But you can make the water go in. Tip the glass a little bit. A bubble of air goes out and up. When the air goes out, there is an empty space in the glass. Water goes in. You can see it. The coloring you added to the water helps you see it. Bubbles go out and water goes in. Keep tipping the glass until all the air goes out. Now it is full of water and the napkin is wet. When the glass was full of air, there was no room for water. When the air went out, the water went in. Air is all around you, and it is all around the earth. It covers the earth like peel covers an orange. Air weighs a lot, 5 quadrillion tons. That's 5 quadrillion tons. That's hard to believe, but it's true. The air in the room where you are weighs more than you think. In an average room, the air weighs 75 pounds or so. If the room is big, the air in it weighs more. If it is small, the air weighs less. We don't feel it because the air is spread all around us. Airplanes and balloons fly in the air, but spaceships don't. Rockets push them higher than the air. Spaceships fly above the air that is all around the earth. Spaceships must take air with them. They have enough to keep the astronauts alive. When they go out of the ship, astronauts carry tanks of air on their backs. They need air to stay alive, and so do you and I. Lucky for us, air is everywhere. Wherever we go on Earth, there is air. Air is even in water. That's lucky for fish. The air is dissolved in the water. You can't see the air, but you can prove that it is there. Fill a glass with water, set the glass aside, and leave it for an hour. After an hour, you will see tiny bubbles on the inside of the glass. They are tiny bubbles of air. The air came out of the water. Fish use the air that is dissolved in water. They have gills that help them do this. Air keeps them alive. We can't breathe air that is dissolved in water, so when we stay underwater a long time, we have to take air with us. Divers take air in tanks strapped to their backs. Air keeps us alive. Wherever we go on Earth, north, south, east, or west, high on a mountain or deep in a valley, there is air. Air is all around us. I hope you guys learned a little bit about yeast and what they do, and also about why it's so important to have air. See you guys next week. Bye!